In the last video, we covered few problems related to algebra of derivative functions. In this video, we will cover few more problems related to product rule and quotient rule. Now let's take this particular problem. Cos x by 1 plus sin x. Let y is equal to cos x by 1 plus sin x. Therefore, dy by dx is equal to, I'll have to use quotient rule here because there is division. Quotient rule. What does quotient rule say? As per quotient rule, I'll say denominator into derivative of numerator minus numerator into derivative of denominator by denominator the whole square. Now using this, we'll solve this. So we'll get denominator. Denominator is 1 plus sin x into derivative of numerator, that is cos x, minus quotient rule will always have minus sign, minus numerator. What is numerator? Cos x into derivative of denominator. Denominator is 1 plus sin x by 1 plus, that is denominator, the whole square. Now let's solve this. So we'll get dy by dx is equal to 1 plus sin x. Derivative of cos x is minus sin x minus cos x. Derivative of 1 plus sin x, we have to find derivative of these two separately. Derivative of 1, it's a constant, so it's 0. Sin x is cos x. Derivative of sin x is cos x by 1 plus sin x the whole square. So I'll get dy by dx is equal to, let's multiply, I'll get minus sin x minus sin square x minus cos square x by 1 plus sin x the whole square. This I can further write as, I'll take minus as common outside. So I'll write sin x plus sin square x plus cos square x by 1 by sin x the whole square. Sin square x plus cos square x is 1, right? The trigonometric formula. Sin square x plus cos square x is equal to 1. This is as per trigonometric formula. So we'll put that. We'll get minus sin x plus 1 by 1 plus sin x the whole square. So this is nothing but 1 plus sin x, right? This is 1 plus, if I rearrange, 1 plus sin x by 1 plus sin x the whole square. So one of this and one of this will get cancelled. So I'll be left with minus 1 by 1 plus sin x. So this is dy by dx. So therefore, dy by dx is equal to minus 1 by 1 plus sin x. Now let's solve this particular problem. Here you have to put product rule. Why? Because you have multiplication here. This is one function, this is one function, and there is multiplication. So what does product rule say? Product rule formula. What is the formula? First function into derivative of second function plus second function into derivative of first function. So let's assume, let y is equal to x plus cos x into x minus tan x. Therefore, dy by dx, if I differentiate, first function is x plus cos x. X plus cos x into, I can take any order. I can take anything as first function, anything as second function. It doesn't matter. D by dx of second function, that is x minus tan x, plus second function is x minus tan x into d by dx of first function, that is x plus cos x. So I've taken this as first function and this as second function. I can reverse it also. So I'll get x plus cos x. I have to find derivative of this separately and of this separately. What is derivative of x? Derivative of x is 1. Tan x is secant square x plus x minus tan x. What is derivative of x? Again, this separately and this separately. Derivative of x is 1 plus cos x. Derivative of cos x is minus sin x. So we have found the derivative of this function. This is the derivative. Now let's solve this problem. If f of x is equal to x to the power n, and if f dash of 1, f dash is nothing but dy by dx. dy by dx, if it is equal to 10, find the value of n. So we'll first find derivative because they've told f dash. F dash is nothing but dy by dx. So f of x is equal to x to the power n. If I differentiate with respect to x, I'll get f dash of x. What is derivative of x to the power n? It's n into x to the power n minus 1. Now, I have to put, instead of x, I have to put 1, right? Instead of x, I have to put 1. So let's put x as 1. So we'll get f dash of 1. So if I put x as 1, I'll get n into 1 to the power n minus 1. And they've told f dash of 1 is equal to 10. This is nothing but, this is 10. So 10 is equal to n into 1 to the power anything is 1 only, right? So I'll get 1. So what is this? 10 is equal to n into 1, which is 10. Therefore, n is equal to 10. Let's solve this particular problem. They've given y is equal to x plus 1 by x. Let's first differentiate because there is dy by dx here. Let's differentiate. Dy by dx is equal to, derivative of x is 1. Derivative of x 1 by x is minus 1 by x square. You can use the formula also, right? You can write 1 by x as x to the power of minus 1, x to the power minus 1, and use the formula n into x to the power n minus 1. So it will be minus 1 into x to the power of minus 1, which is minus 1 into x to the power of minus 2, which is nothing but minus 1 by, I can bring x down. So it will become, negative power will become positive power. So minus 1 by x square. Or I can by heart this derivative. 1 by x is always, derivative of 1 by x is minus 1 by x square. So now I'll take the LCM. LCM would be x square. Assume that there is 1 here. So this will go x square times. If I have to get LCM as x square, I have to multiply 1 by x square. Only then I'll get x square. But I have to multiply numerator. Right? I have to always multiply numerator. So I'll get x square into 1 is x square. And to get x square, here I have to multiply 1. So I'll multiply numerator as 1. Numerator with 1. So 1 into 1 is 1. So dy by dx is equal to x square minus 1 by x square. Now I need to get this particular expression, right? So I can shift x square here. So I'll get x square into dy by dx equal to x square minus 1. But I need to get xy plus 2. Now what I can do is, let me take this function. I can say y is equal to x plus 1 by x, which is nothing but, if I take LCM, what will happen? It will be x square plus 1 by x. X square plus 1 by x if I take LCM. Right? This is y. So now I'll shift x this side. So it will become x into y is equal to x square plus 1. So x square plus 1 is x into y, which means x square is equal to xy. I'll shift 1. So it will become minus y. X square is xy minus 1. So what I can do is, instead of x square, I'll put this xy minus 1. So what do I get? I'll get x square into dy by dx. Instead of x square, I'll put xy minus 1 and minus 1. Right? This minus 1. I'll shift all this to one side. Right? So what I'll get? Minus xy. Minus 1 is minus 2. When I shift this side, it will become plus 2. And I'll be left with 0. Why 0? Because I shifted this entire thing to this side. So it becomes 0 here. So I have proved the statement. This expression is proved. So I would say, hence, proved. Now let's take this problem where we have to differentiate with respect to x. Here I have to apply quotient rule. Here separately. Here quotient rule. Here also quotient rule. Why? Because there is division here. I'll apply it separately. Let y is equal to 2 by x plus 1 minus x square by 3x minus 1. So dy by dx is equal to, what is quotient rule? What is the formula? Denominator into derivative of numerator minus numerator into derivative of denominator by denominator the whole square. So this will be, let's apply it separately. So this is denominator, right? So denominator into derivative of numerator, which is 2, minus numerator 2 into derivative of denominator, which is x plus 1, by x plus 1, that is denominator the whole square, minus, this is only 1 for this one. For this one we'll have to do. So this will be denominator 3x minus 1 into derivative of numerator, which is x square, minus numerator into derivative of denominator, that is 3x minus 1 by denominator the whole square. So I'll get dy by dx is equal to x plus 1 into derivative of 2 is, it's a constant. It is 0. Derivative of 2 is 0. Right? Minus 2 into derivative of, what is derivative of x is 1. Derivative of 1 is 0. So derivative of x is 1. Derivative of 1 is 0. So 1 plus 0 is 1. So I'll get 1 year by x plus 1 the whole square. Now minus, let's go to the second one. 3x minus 1, derivative of x square is 2x, minus x square into derivative of 3x. Derivative of 3x is 3 and 1 is 0. 3 minus 0. So it is 3 by 3x minus 1 the whole square. Now let's try to simplify this. Right? This is going to be 0, minus 2. Minus 2 by x plus 1 the whole square minus, let me multiply this, I'll get 6x square minus 2x minus 3x square by 3x minus 1 the whole square. If I subtract this, I'll get, let's write down this, 6x square minus 3x square is 3x square minus 2x by 3x minus 1 the whole square. Now I can take x common. I can take x common here. So I'll get minus 2 by x plus 1 the whole square minus x, if I take as common, I'll get 3x minus 2 by 3x minus 1 the whole square. So here's the derivative. Now let's differentiate this particular problem. Let y is equal to 2x log x by root x. Note here there is multiplication, right? And here there is division. So I'll have to apply both product and quotient rule. Both the rules have to apply. First, let's apply quotient rule, right? First quotient rule. So dy by dx, quotient rule is denominator root x into derivative of numerator. What is numerator? 2x into log x minus, now we'll take numerator. Numerator is 2 to the power x into log x. This entire thing is numerator into derivative of denominator. What is denominator? Root x by denominator the whole square. So I'll get dy by dx root x. Now I have to differentiate this. Here I have to apply product rule. Here I have to apply product rule. What does it say? First function, let's take first function 2 to the power x into derivative of second function, that is log x, plus second function into derivative of first function. This is first function 2 to the power x minus 2 to the power x. I'll copy the rest. What is derivative of root x? 1 by 2 root x. Right? I can write x as x to the power half. Root x as x to the power half. And then apply n into x to the power of n minus 1 formula. Right? So 1 by 2 root x. Let's solve this. Root x, derivative of log x is 1 by x plus log x. Derivative of 2 to the power x is, what is derivative of 2 to the power x? So there is a formula here, right? Derivative of a to the power x, a is any number. Derivative of a to the power x is a to the power x into log a to the base e. So a to the power x. Instead of a, this is nothing but a to the power x. Right? What is derivative of a to the power x? It is a to the power x into log to the base e, log of a to the base e. Instead of a to the power x, we have 2 to the power x. So 2 to the power x into log base e, and a is 2. Right? Minus, let's copy everything, by 1 by 2 root x. We forgot the denominator. So this is a mistake. We'll have to copy this denominator here by x. Let's simplify this, right? Here we have 2 root x, right? We will have to simplify. We assume it's 1 over here. Let's take LCM. So LCM would be 2 root x. Let's not forget this x. LCM is 2 root x. So you assume that there is 1 over here, right? So if I have to get LCM as 2 root x, with what should I multiply? I should multiply with 2 root x, because 1 into 2 root x is only 2 root x. So I'll multiply numerator with 2 root x. So I'll get 2 root x into root x, right? And then copy everything as is. 2 to the power x by x plus 2 to the power x into log 2 into log x minus 2 to the power x log x. This 2 root x is anyway common. So here I have to multiply it once. To get 2 root x's LCM, I have to multiply it with 1. I have to multiply numerator with 1. Right? So 2x log x, 1 into 1. By 2 root x, this is the LCM, by x, this denominator. Assume that this is 1 here and I take it on top, so it will become 1 by x. So I'll get dy by dx is equal to 2 root x into root x is x itself, 2x. I'll get 2 to the power x by x plus 2x log 2 into log x minus 2 to the power x log x by 2 root x. If I take this on top, x by 1 will become 1 by x. It will become reciprocal. 2 root x into x is nothing but, you can write it as 2 to the power, root x can be written as x to the power half into x. So since the bases are same, that is x and x, there is no power here, I can assume it is 1. I can add the powers. So it will be half plus 1, which is 3 by 2. Right? Now therefore, dy by dx, instead of 2 root x into x, I'll write 2 into x to the power 3 by 2. 2 into x to the power 3 by 2. This one. So derivative is this entire expression. Now let's take this problem. You have to prove cos square x into dy by dx is 2 minus sin square x. Let y be this. Since there is dy by dx here, we'll have to differentiate. Differentiate with respect to x. We have to find derivative. So dy by dx is equal to x plus tan x. Derivative of x is 1. Tan x is secant square x. Secant x is 1 by cos x. Correct? Let me write it. Dy by dx 1 plus 1 by cos square x. Now if I take the LCM, I'll get cos square x as the LCM. Assume that this is 1 here. So I have to multiply into cos square x and into 1 here. So 1 into cos square x plus 1. Because if I have to get LCM as cos square x, I have to multiply here with cos square x. Cos square x into 1 is cos square x. Right? But I multiply the numerator. So cos square x plus 1. Now I'll shift cos square x this side. Right? I shift it here. What will happen? I'll get dy by dx into cos square x is equal to 1 plus cos square x. Now, I need to get 2 minus sin square x. I got cos square x. I got this portion. Right? I got this portion here. I need to get 2 minus sin square x. I have 1 plus cos square x. What do? There is a trigonometric formula. What is it? Cos square x is equal to 1 minus sin square x. How? Cos square x plus sin square x is equal to 1. Right? So, what will be cos square x? Cos square x is 1 minus sin square x. So, I'll write, instead of cos square x, I'll write 1 minus sin square x. So, what is this? 1 plus 1 is 2. 2 minus sin square x. So, cos square dy by dx is equal to 2 minus sin square x. Hence, proved. So with this, we have come to the end of this particular topic. If you found this video useful, do press a like and share it.